see if I have enough space here. I do. For step 4, concavity, where we are going to look at the second derivative, which means we take the whatever form of the first derivative you want. And I'll pick this first one to easily take the derivative. So I'm going to have for my second derivative, it's going to be negative 12x and then it's going to be plus 6. So there's my second derivative. Then we do our check. Second derivative equal to 0 when? Second derivative undefined when? Well, undefined never, because it's a polynomial. But it is going to be equal to 0 if I factor this out a little bit. Maybe I want to take out a negative 6, let's say. And then I'll have 2x minus 1. So when I multiply it in, I get the original back. So I see then that the function is going to be 0 when x equals 1/2. So that is my potential inflection point. Then I like to make a little table to see how the pieces interact. The only number that I'm going to mark off is 1/2, and I'm listing everything on the left. Together, they make my second derivative. So, I have my x-axis, my x values split up into 2 intervals. Negative 6 is always negative. 2x minus 1 is going to be 0, we said, when x is 1/2. And because it's all multiplication, it makes the second derivative 0. Use representative numbers or however you want, but 2x minus 1 is going to go from negative to positive. Now, because it's multiplication, 2 negatives will make a positive, 1 negative will make a negative. And my function, my original, my graph is going to bend up in some way and down on the next section. What are, if any, my inflection points? Well, for the inflection points, I have 3 criteria. It has to come out of this list up here. It has to be a point on the graph. On my original, because my original is a polynomial, it's defined everywhere, so I do get a y value, and the concavity changes. That is another requirement to be an inflection point. So I just have to find the corresponding y value, and I have my inflection point. So let's go up here to see what the y value is when x is 1/2. So I have negative 2 times 1/2 cubed. Then I have plus 3 times 1/2 squared. I'm going slowly so that if you need to, you can follow along. Not everyone is skilled in the calculator in the same way. Plus 12 times 1/2 plus 2, and I get 8.5. Now we can mix the decimals here. You can go here and say this is 0.5 and then y is 8.5. You can mix it up. You can do whatever makes you more comfortable. Then we'll sum it up by saying f is concave up on the interval negative infinity to 1/2 or 0.5. F is concave down on, I'm running out of space, 1/2 to infinity. So we have this point 1/2 and 8.5. So 1/2, let's put it over here. 8.5, let's put it over there maybe. And again, I am abusing the scale for convenient shape. So I'm bending up and I'm bending down as I go past that inflection point. Now we have a lot of rough things on this graph over here. Let's clean it up with our final graph and have a graph that's nice and neat with no real regard to the scale. I'm interested in the beginning especially to focus on the shape and let the points sit where they are, and I'll indicate them as I need to. So I have my point here, -1, -5, that's my critical point. I have my y-intercept of 2. I have an 8.5, that was my inflection point. Put that over, not over there. I have to be a little bit closer. 1/2, let's say that point's over there. Then at 2, let's put that up here. I think that was a 22, and that'll sit at x equal to 2, and that should be good. So let's do the left first here. We start horizontally. It's actually hard to draw on this tablet. And then I will go to infinity. Then we start horizontally, bending up. It's a little wonky here, I know. Bending up through to the inflection point where it changes to bending down. Looks a little straight there. It's a very slight bend, and then I'm going through that top critical point down to infinity in some direction. I don't know. Whoopsie, got away from me there a little bit. Let's try and be a little wider. And just go. Whoop, that is too wobbly. It's hard on my tablet. I draw, but I can't see my hand. So it's hard to get the angle just right. But we get the idea. As smooth as you can make it. Doesn't have to be perfect. You can always look at online graphing tools to graph it perfectly. By hand, it's always going to be a little wonky. So that is our first type of function, a polynomial, going through all the steps from start to finish. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.